Hi guys, welcome back. Today we discuss about Kubernetes. What is Kubernetes? Kubernetes is an open source container orchestration platform used to deploy applications, scale applications, manage containerized workloads automatically. Originally developed by Google, now maintained by CNCF, Cloud Native Computing Foundation. By the name Kubernetes, Greek word meaning helmsman. Helmsman mean ship controller, abbreviated as K8S, eight, le- eight letters between K and S. That's we call it as K8S as well. And why Kubernetes is needed? Without Kubernetes, manually start stop containers, no auto scaling, no self healing, difficult networking between containers, manual load balancing, no rolling updates. So without Kubernetes, so these are the disadvantages. And advantages with Kubernetes: automatic container management, auto scaling, self healing, built in networking, load balancing, zero downtime deployments. So with Kubernetes, so we can achieve all these things: automatic container management, auto scaling, self healing, built in networking, load balancing, zero downtime deployments. So Kubernetes architecture like this. First, it contains control plane. So it contains master components. Under that, worker we get worker nodes, worker node 1, worker node 2, worker node 3, like this. And Kubernetes control plane master components. So Kubernetes control plane also called as master components. So it contains one Kube API server, Cube API server. So entry point for Kubernetes, all commands go through API server, exposes REST APIs. So this is the entry point of Kubernetes. All commands go through API server. So all commands go through this server and exposes REST APIs. So it works with REST APIs. So next one is etcd, etcd database, etcd or etcd database. So it contains distributed key value store, stores cluster state and configuration, critical for cluster recovery. So it works on distributed key value store, stores cluster state as well as configuration, critical for cluster recovery. So whenever cluster has problem, and so for recovery it is useful. So this is also one of the main component. And kube scheduler decides which part runs on which node. So this does actually kube scheduler does decides which part runs on which nodes. Considers CPU, memory, node health, states, and tolerations. So it considers CPU, memory, node health, states, and tolerations. Cube controller manager. Next one. So, Cube controller manager runs multiple controllers, node controller, replication controller, endpoint controller, ensure desired state is equal to actual state. So it will ensure that desired state, that is the actual state, how many parts are running, so how many clusters are running. So that all it will take care. So cloud controller manager, fifth one, integrates with the cloud providers, manages load balancers, disks, VM lifecycle. So it will manage load balancers, disks, VM lifecycle. So cloud controller manager. So worker node components. So usually we work on worker node components, and that master node components will take care by service provider, cloud service provider. Okay. So we handle with worker node components. Each worker node runs kubelet. So one is kubelet. So kubelet is agent running on every node, talks to API server. So kubelet will talk to API server and ensure containers are running. So it will ensure that containers are running. So next one is container runtime. So this is second one in worker node components. Runs containers, example container CRI-FNO, Docker deprecated this one. So container runtime. So it makes sure that containers run containers. Okay. So proxy. So third one is proxy in worker node components. And so proxy, it will handle network proxy, handle service networking, implements load balancing rules. So these are all kind of things it will handle network proxy as well as handle service networking, implements load balancing rules. And Kubernetes core objects. In Kubernetes, there are core objects, and so that is one is pod. Yeah, actually, it is very important. Pod actually, pod is nothing but smallest deployable unit, one or more containers. So it contains one or more containers. It shares network storage IP. Pod containing container 1, container 2, like that. Container 3, container 4 also. Pods are ephemeral, can die anytime. So pods can die anytime means yeah, it may die, it may get problem anytime. Uh, in that case, it will automatically deploy the pod containers like that. So Kubernetes will make sure that. Next one is replica set, ensures the desired number of pods. So replica set ensures that a desired number of pods are running. If pod dies, new pod created automatically. So replica set will take care of ensure desired number of pods. How many pods we have configured. So it will ensure that the desired number of pods are running. If pods dies, a new pod created automatically. Whenever any pod is dies, that means it's not working. So new pod should be created automatically. So replica set will take care about that. Deployment. So next one is deployment. It manages replica sets. So supports rolling updates, rollbacks, scaling. So deployment makes sure that it supports rolling updates, rollbacks, scaling. Deployment is called replica set under that pods. Service. So next one is service. Service exposes pods to network. So service ensure that it should expose to pods to network, provide stable IP and DNS. So whenever you provide stable IP and DNS only, it will communicate to other pods. Service types. So in services there are some types, and that is the number one is cluster IP. So description internal access. Cluster IP, if you provide cluster IP, it is useful for internal access of pods. And the node port, access via node IP. So access via node IP. Node port useful for access via node IP. And a load balancer. Cloud load balancer. It is a cloud load balancer. External name, map external DNS. So if any external DNS is there, we can map with external name. Namespace. So namespace is a logical isolation. So useful for dev test prod. So namespace is like it's a logical isolation. So we can isolate with namespace like dev test prod and so on. Volume. So volumes useful for persistent storage. And the data survives pod restart. Types MTDIR, host path, persistent volume PV, persistent volume climb PVC. So it contains these all parameters, and so we will configure it. Kubernetes networking. So every pod gets its own IP. So pod can talk to each other without NAT. So pod can talk to each other without NAT. Without NAT, it talks to each other internally. Service provides provide services provide stable access. So it will provide stable access. CNI plugin handle networking, Calico, Planel, Planel, and Azure CNI. So Kubernetes networking contains all these things. And the scaling in Kubernetes. So in Kubernetes, there are kind of scaling, horizontal pod autoscaler, HPA. We call it as HPA, horizontal pod autoscaler. S- Sales pod based on CPU, memory, custom metrics. So it will scale parts based on CPU, memory, custom metrics. Cluster autoscaler, horizontal pod autoscaler, as well as next one is cluster autoscaler. Adds removes nodes automatically. So this will handle add removes nodes automatically. Self-healing features. So Kubernetes self-healing features are there. So any prod crash, it will restart. Node failure, reschedule parts. So any node failure is there, it will reschedule parts on another node. So that will make sure that health checks. So in the self-healing features, health checks are there. Liveness probe, readiness probe, startup probe. So it contains these all things. Rolling updates and rollbacks. Update without downtime. So it will update automatically without downtime. Control max search, max unavailable. So it will control max search and max unavailable. Rollback anytime. kubectl rollout undo deployment app name. So this is the command kubectl rollout undo deployment app name. So this is the command. By using this, and we can roll back anytime. Kubernetes security. Key security concepts in Kubernetes. First one is RBAC, role-based access control. And by using service accounts also, yeah, there is security. And secrets. By using secrets, passwords, tokens like that. So by using that, we maintain the security and network policies. By configuring network policy, we maintain security and pod security standards. So pod also has some security standards. So by doing that, and the key security concepts will achieve. And Kubernetes in cloud. So how Kubernetes in cloud and benefits, no master management. So master management we don't do, as we discussed just ago, and so master management will take care by cloud provider. So no master management, no master management. Auto upgrades also we don't do, automatically taken care by cloud service provider. And integrated security. So security also will manage by cloud providers. So different clouds, Kubernetes service names. Azure AKS, Azure Kubernetes Service. AWS Elastic Kubernetes Service, and GCP Google Kubernetes Service. So we call it actually different clouds. We call it as different names: Azure AKS, AWS EKS, GCP GKE. Example application flow in Kubernetes: user use load balancer service, use deployment. Under deployment, create pods containers. Under pods pods contain containers, and deployment contains pods. So this is the workflow. Kubernetes versus Docker. And what is the difference between Kubernetes versus Docker? Docker build containers. Kubernetes runs container at scale. So only Docker is for only building containers, but Kubernetes is for run containers at scale. So Kubernetes orchestrate the Docker containers. Feature. So feature Docker feature, Kubernetes feature. We are comparing container runtime. So container runtime, Docker has container runtime. Kubernetes doesn't have container runtime. So Docker especially used for containers only, and Kubernetes don't don't manage container runtime. And what about orchestration? Orchestration in Docker there is no orchestration. Kubernetes orchestration will be possible, and auto scaling. Docker auto scaling is not possible, and Kubernetes auto scaling is possible. Self healing, Docker it's not possible. Uh, Kubernetes self healing is possible. So, um, so based on this comparison, what we can know is like container runtime only Docker manage only container runtime, and orchestration, auto scaling, self healing it doesn't manage, and Kubernetes doesn't maintain a container runtime, but it will orchestrate, auto scale, and self healing. It manages all these things. So real world use cases. So it's Kubernetes is microservices, and using in CI/CD pipelines, blue green deployments. So blue green deployments means development and production like that. Blue green deployments are like that. Multi cloud apps. So it useful for multi-cloud apps. So you created a different application in different clouds. So that also Kubernetes manages high availability systems. So Kubernetes manages high availability systems. So learning path. So learning path we can learn containers and Docker. So Kubernetes basics you can learn YAML manifests. So YAML manifests it contains deployment services, replica sets like that. Networking and storage. So, so we have to learn networking and storage and security, RBAC and secrets. So, beside that, we have to learn Helm. So, Helm is for installing application in sorry, installing application in containers, pods and all. So it will manage the application deployment and all. So any third party application we have to install in any parts. So we use Helm. Monitoring. So for monitoring we use Prometheus, Grafana. Actually for dashboards we use these two things, and also other things also there, but these are widely used in the environment and the industry. Prometheus as well as Grafana. So what is AKS, EKS, GKE? So these all things we learn. So simple Kubernetes YAML example. So when we are configuring this one YAML manifest file, so we use all these parameters: API version, apps version one, kind. So what kind of deployment we are giving? This here in this example. So kind is deployment. So metadata name, deployment name, nginx hyphen deploy, specifications, replicas. How many replicas we should maintain? So replicas 2, selector, match labels, app nginx. So all replicas 2, all the specification should be the same name. App is equal to app name is equal to nginx template. So template where it should get metadata labels, app name nginx, and the specification. So container specification we are providing, name is called nginx, image, so image where it get from, that is also nginx, so it is getting from nginx image. Ports, so we are giving for container port number and container port 8080, so that is http port. So simple yeah, Kubernetes deployment is like that. And so we can yeah yeah later chapters we can give complex deployments also. So this is all about Kubernetes. Thank you guys.